Let's see how we can implement while loop in MIPS Assembly Language. Assume that we want to write a program to compute the summation of an integer numbers, so assume that the end will be entered by the user. And we want to compute the summation of 1 plus 2 plus 3. Pn. This is my solution. As you can see in the data segment, I declared two messages. One prompt for the user to enter value n. And after I find the submission first, I will print this message and then print the value by using a system called. So in this part, I display the first message on the screen and then I will read one integer by using system called number 5 and store it in a temporary register T0. In order to find the summation, we need a sum variable and it should be initialized by 0. Also, we need the counter to implement the loop. So for this purpose I use registered T1 as the loop counter and initialize it by 0. And also I used register T2 for the summation. This is the loop body. As you can see, first we add one unit to the loop counter and then we will add it with the previous summation and store it in the sum. So this part is equivalent to I increment. And this part is equivalent to the sum. Equals sum plus I. After one iteration, we should check the loop condition. If I become n, it means that we should go out and print the summation. So branch equal. If the I is this is the it1 and this is the end that I received from the keyboard in this part and store it in the T0. So if these two registers content are equal, then we should go out. Otherwise we come back to the loop and add the next number to the previous summation and keep it in T2. So when we move out from this loop, the summation is inside $92. So in order to print it, first I print a message sum equal by using system card number 4 and then 2 will be given to the or will be moved to the register or sign a 0. And by using system code number 1, we will print an integer number in the end of the program. In order to exit the program, we can use a specific system call number 10 in order to terminate the program completely. Let me run it. Number of integers, for example, 10. Summation is 55. The summation of 1, 2, 3 till 10 is 55. We set it and clear it. Submission of number between 1 to 100 is 5050. So in this code we implement a while loop by using simple branch equal and unconditional jump. With the killer her look contour. And after we performed the look body in this part, we check the condition. And if the condition is not satisfied, we will move out from the loop. Otherwise, we will come back and repeat this loop again and again. You know how we can write a program to read 5 numbers from the keyboard, then store them in one array and finally find the maximum element of this array. First of all, I need to declare an array. For this purpose, we use that a space assembler directive. My array is the name that I give to my array and that a space reserve the next specified number of bytes in data segments. So I want to store 5 numbers inside my array, and since every number needs 32 bits or 4 byte, I need 20 bytes to store this number. So this is the way that we declare an array in MIPS assembly language. In line 3 I declare my variable max, initialize it to 0, and also I declare to a string prompt 1. Enter the array elements message and max message, which will be used before we print the maximum value. By these 3 lines, I will show you the prompt 1 on the screen, and I use registered dollars and T0 as the array index, and registered $10 as the loop counter. Since I want to read 5 numbers, I need the counter, and in order to access the element of the array, I need the index variable by these 2 lines. I read 1 element from the keyboard and it will be inside the V0 or 0. Then I will store it in the array index I. My array index C0 in the beginning initialize with 0. So in the first element I store in the my array index 0. For the next element, I need to update this index. So since every element need 4 byte in order to update the array index, I should increment or add 4 unit to the array index variable. So T0 will be increment by 4, or we will add 4. You need to T0 in order to go to the next element. Also I need the loop counter as 0. It should be updated here, and we will check the value of the 0. If it is less than 5, we will come back to the label loop with another value and store it in my array index T0. You know that the store-bought instructions store the content of this register in the address that are achieved by adding my array and the content of this register together. So for example, if my array or startup list of the array is 10 and T0 is 4, then the content of $V0 will be stored in memory location address 14. After this loop finished, we have 5 elements inside the myArray variable. Now I want to compute the maximum element again. We should start from the beginning of the array, and as you know, for finding the maximum, we will consider the first element of the array as the maximum and then start searching from the second element till the end of the array. If we find any element which is greater than the previous maximum that we compute, we have to update the maximum and consider this new element as the current maximum. So let me write the pseudocode for this algorithm. So in the high-level language, we use this algorithm. Well, we consider the first element as the maximum. Then we start from the second element till the end of the array. We will check if we find some elements inside the array which are greater than the maximum that we found. We will change the maximum. And now from this moment, this array index IE is the maximum. So here in a set of maximum, I use the register. But our sign 0 is the maximum variable in this algorithm. And I read the first element of the array and store it inside the registered $sign as 0. Now I should start from the second element. So the loop counter starts from $1.91 is the loop counter and $30 is the array index. So if it is equal to 5, go to the end. Otherwise we should read one element from the array. We have to add 4 unit to the array index to refer to the next element in the array. So I read an array index 2 and put it inside $sign as 1. So my maximum is inside the sign 0 and array index I is here inside the $sign as 1. Now I should check them. Branch if greater or equal, if the maximum is greater than array index I. We don't need to change anything. Otherwise we have to consider this element as the new maximum. So I move the content of registered $sign as 1 or array index 1 into my max variable. Anyway, we come to this line and now we should add 1 unit to the loop counter and we come back to the again and check the loop condition. When the T1 becomes 5, it means that we compute the maximum and it is inside the sign as 0. I print the max message prompt and finally by the system call we can print the content of registered $sign as 0. As you know, we should put this one inside the 0 and system. Call number 1 is responsible system called for printing an integer. Also, I save it inside the variable max. Let me run this code. Enter the elements 5 and 8, 9, 7. Maximum is 10. Also, if you come here, you can see the element that I entered are stored in memory. This is the address of the first location of the memory. And the next element is stored in this address, plus for this address plus 8 plus C or 12. Oh, this is the content of the first element of the array. 5 This is the 10 that I entered 8 and 9 and 7. And this is the variable max picture here. The first 5 words of the memory are used as the array. The next element is used for the max variable, and after that we store some ASCII code inside the memory card. Here this is the array. Part is 5 words. This is the max variable and this is the ASCII code for 4 character, the first 4 character. This is the 4545 in the hexadecimal means 4 times 1664 plus 569. This is the ASCII code of the character E. And then ETE all of these for character E and T and E all of this 4 character ASCII code can be found here. This is the first one, E this is the second one, third one, and 4th character ASCII code, and again, 4 other character or a space. T and H are in the next memory location, so you can see the memory content in the data segment.